Brand new chapter, chapter 8, lesson 8.1a. We're going to work with inequalities in this chapter, and today we're going to work with compound inequalities that have and. Now remember, inequalities are the greater than or less than. It's something that's not equal to. Inequality, got it. And compound inequalities are when we have more than one together. And if we use the word and, that means that we're going to have an intersection. The intersection of two sets is the elements that are in both of those sets. So an intersection is something that is included in two different sets. So in this case, in my example, I've got the set A is the numbers 1, 2, 3, 4, 5, and the set B are the numbers 3, 4, 5, 6, 7. So the intersection, which this little upside down U is the symbol for intersection, the A intersected with B is all of the elements that are in both. So we can look to see 3, 4, and 5 are in both. Now the 1 and 2 are only in A, 6 and 7 are only in B, but our set that is the intersection of both is the set of 3, 4, and 5. So, oh, that's just lovely. So the first part of your homework is just do the intersections. So the first 4 problems where I say just do part A, those are just the intersections. We'll do the unions tomorrow or in the next section. So the intersections are the numbers that are in both sets. All right. So now what that looks like in graph form is this. So if I have x is greater than 4 and x is less than or equal to 7, what I mean is this. So 4 and 7 are points of interest. So we're going to just put 4 and 7. Make sure they're in the right order on your number line. So if x is greater than 4, that means that anything to the right of 4 is included in this graph. And if x is less than or equal to 7, and now this is not equal to, so we have a curved line. If x is less than or equal to 7, that means that starting at 7, we go everything to the left. So the intersection is where it's both and. So the parts where it's both and are between 4 and 7. All right? So the way we can show that, this is going to be important. You're going to have 3 different ways to show it. First of all, you can say, well, x is between, so 4 is less than 7 is less than or equal to, 4 is less than x is less than or equal to 7. So what you've done here is you've put this x in between the 4 and the 7, making sure to keep your signs facing the right way. Now watch here, this x greater than 4, the open end is still toward the x, all right? So in order for this to be a true and statement, your numbers, your signs have to both be less than. Oops, and now it looks like less than or equal to. All right, so 4 is less than x is less than or equal to 7. So that's the first way. The second way you can show that is with the endpoints. So the 4 and the 7 are our endpoints on our graph, and we're going to have an open point on the left because it's not equal to, and we're going to have a hard ending or a closed point on our 7 because it is equal to on the 7. And I think that we've done this part before, so this is just oh yeah, remember. So the curved line is come up to here but don't include it, and the hard line is you come right up here, we're going to include this number. So if it's equal, then it's a straight line. If it's not quite equal to, it comes up to here but we don't want to touch, then we have a little curvy line. All right. Okay, and then your graph is going to be, so we've got 3 different ways to show our answer. The graph is going to be exactly what we have here. 4 and 7 are the endpoints. It's gonna look just like this. We've got a soft endpoint at 4 and a hard endpoint at 7, and then you color what's in between. Okay, or shade in. Don't have to color it. All right, here we go. Let's do, so now what we need to do, sometimes we don't have just an x is greater than or less than. We've got this whole expression. So what we're going to do is this. We're going to have to solve those inequalities. And I've got just some steps here. So to solve the inequalities with and, step 1 is simply to solve each inequality separately. So pretend like you don't have both in the same problem. Just relax, take one little part at a time. And so just do each inequality separately. and then compare those graphs. Compare the graphs like we did here and find the intersection of the two solutions. And the intersection of the two is your final solution. Let me show you what I mean. All right, so step 1, just solve each inequality. So I've got 3x minus 1 is greater than 2, and 2x plus 4 is less than or equal to 14. So both of these we're saying, I want the answers to both of them on the same graph or in the same answer. So what you need to do is, you need to find out the answers to each of them separately. So let's do that. In this problem, to solve for x, we're going to get x alone, so add 1 to both sides. 3x is greater than 3, divide by 3. So x is greater than 1. That's part of your answer. And over here, you're going to subtract 4 from both sides. And I'm going quick because hopefully by now you know how to solve these. You pretend like they're just equations, just solve them and keep your same sign. So 2x is less than or equal to 10, divide by 2. So x is less than or equal to 5. All right, so these are our two endpoints. So let's get ourselves a little graph going. And we've got 1 and 5. 1 is the smaller one. And we've got x is going to be greater than 1, so it's going to be a soft endpoint, and it's going to go to the right. And let's see, x is less than or equal to 5, so it is what's in between there. So this is our solution graph, and then we can just do the endpoints just like we did before. 1 and 5 are the endpoints, and this is not equal to, and this is equal to. And so then we can say, okay, well, if it's the points in between, so x is going to be in between 1 and 5. So 1 is less than x, which is less than or equal to 5. All right, that's how I do it. I put my x first and put my two endpoints around it, and then put your symbols in between. So all three of these are your answer for that problem. All right, same type of thing. Let's do another one. With this, if they've already set it up as this is an and statement. So -2 is less than or equal to -3x plus 7, and this is less than or equal to 1. So what you're going to have to do in this case is you're going to have to split it up into two inequalities. You need to solve each one of those inequalities, so split it up into the two different inequalities. So -2 is less than or equal to -3x plus 7, and -3x plus 7 is less than or equal to 1. Then solve each one separately. Add 7 or subtract 7 from both sides. -9 is less than or equal to -3x. Okay, put a big star here, and you might want to put it on your note part. Make sure that you don't forget when you divide by a -3. When you divide by a negative, you reverse your signs. Divide or multiply. When you divide or multiply by negative, use the opposite sign. Okay, so what I mean by that is, that's just lovely writing. Hopefully yours is better than mine. All right, when you divide, so now this positive, so negative divided by negative is a +3. This less than becomes a greater than or equal to. Okay? So if you multiply or divide by a negative, your inequality sign is going to be flipped. All right? So now 3 is greater than or equal to x. And subtract 7 from both sides. -3x is less than or equal to -6. Divide by -3. I'm dividing by a negative. So again, x is greater than now. Greater than or equal to +2, because negative divided by negative is a positive. All right, so now, same thing we did before. Let's put our little number line up here. And we've got 3 and 2, so 2 goes first and then 3. So let's see, 2, x is greater than 2, so it's going to go to the right, and it is a hard ending. And x is less than or equal to 3. So x is less than, so it is in between. So we've got the points 2 and 3 with hard endings on both ends. and x is between 2 and 3. 2 is less than x, which is less than 3. Except they're both less than or equal to. You got all those parts and pieces? Woo. All right. Let's do a couple more because so make sure. The big thing on that is if you multiply or divide by a negative, make sure you flip your inequality sign. Let's do another one. Here we go. Let's subtract 11 from both sides. And 2x is greater than or equal to, what is that, -6? Now I'm going to divide by 2 here. But this 2 is positive that I'm dividing by. Don't get confused. If this is a -6, we still just divide by the positive 2, and x is greater than or equal to -3, and we're good to go there. Do the same thing on the other side. Subtract 11. 2x is greater than, what is that? 3, 11, 10, 9, 8? -8? Yes. So now divide by 2. So x is greater than -4. All right, and we have our greater than equals in the right place. Okay, good to go. So far, so good. So we're going to have our number line. And be careful when you have your number line with negatives, because remember it counts backwards. So -3 is on this side and -4 is on this side. All right, so now x is greater than -3. So x is this way on -3, and x is greater than -4. So at -4, it's going to go this way. So what we're looking for is, we're looking for the intersection, which means it has to be in both, right? And now this one didn't go in between. The graph didn't go toward itself, so it's not a quick, easy, oh, this is where it's in between. So this one, with this graph, x is greater than or equal to -3, it goes to the right. And x is greater than -4, it goes to the right. So now we've got to determine, okay, well, where are we in both? If you're anywhere between this -4 up to this -3, you're only in this solution. You're not in this solution because this one says it has to be greater than -3. So this is going to be your whole solution set, because this one starts at -4 and it includes everything to the right. This one doesn't start until -3 and then includes everything to the right. So your solution set for this is not in between 2 points. Your solution set here is from -3 all the way to infinity. And this is an equal to, so it's still a hard point. And now so your graph then looks like this. The end starts at -3 and it goes to the right. And then instead of having x in between something, we can say, actually, this is our solution. X is greater than or equal to -3. So remember that your solution has to be, your solution for an intersection has to be the solution for both. It has to be the intersection. It has to be within the solution set of both of your parts, both of your inequalities. All right, here we go. Easy sneezy. Intersections, all you have to do is you know how to solve inequalities. You just have 2 in each problem. So solve each inequality and then put them together, and where's the intersection? No problem. See you next time.